Welcome to our third lesson on plane geometry. The learning goals for this lesson will be to use different properties of triangles to find unknown angles. We started this lesson by doing an investigation where we used a protractor to find the three angles in each of these triangles. So for triangle ABC, we found angle 1, angle 2, and angle 3. And we wrote those angles in this table. Because protractors are hard to be exact when you use them, everybody's answers will be a little bit different. And then you could do the same for triangle DEF and finally for GHI. So if you'd like to do this investigation, pause the video and you can try it now. But to summarize our results, once you find the three angles from each triangle, they should add up to 180 degrees. Again, this might be a little bit off because when you measure with a protractor, it's hard to be exact. So that brings us to our first theorem, triangle theorem. And that states angle sum in a triangle, AST, is when the three angles in a triangle sum or add to 180 degrees. The second theorem is the isosceles triangle theorem, or ITT. This says in an isosceles triangle, which has two equal sides, the angles opposite the equal sides are also equal to each other. And we will see this on the next page. Here we have an isosceles triangle. It's identified because these lines both have two little lines indicating that they are equal to each other. So we look at the angles opposites, each identical length, and those two are going to be identical. So angle A is equal to angle B. And again, you can check this with your protractor. You can measure angle A and angle B, and then you can measure angle C. What you will notice is that A and B are the same, and the three of them should add up to 180. And the final theorem is the equilateral triangle theorem, ETT, and that states that in an equilateral triangle, which has three equal sides, all three of those angles are 60 degrees. So here we have a triangle that looks to be equilateral, and I will tell you that it is, and we should indicate that by writing the three lines on each length, and that means all three of them are the same. For all angles to add up to 180 and for them to all be equal, they all must be 60 degrees. 60 plus 60 plus 60 is 180 degrees. Questions 1 to 4 are for you to practice using the theorems that we just looked at, but I will do a couple from each 1, 2, and 3. I will do a couple just to show you how to use these theorems. So in question 1, it says to use AST, which states that the three angles in a triangle add up to 180 degrees. We're going to use that theorem to determine the unknown angle. So in A, our unknown angle is x. I also know that the other two angles are 68 and 60. So to find angle x, I'm going to subtract 68 and 60 from 180 degrees. You could have also added those two together and then subtracted from 180 degrees. Either way, you will get the answer of 52 degrees. Again, I gave my answer, and then I also gave the reason of AST. I will now do C. In C, I am given an angle of 57 degrees. I'm given an angle of 90 degrees. That's what that little square indicates. And I have to find angle Y. So to find Y, I take 180 degrees, subtract the angles that I have, 90 and 57, and I'm left with 33 degrees. And in brackets, again, I used AST to find my unknown angle. In question 2, I have to use ITT, the isosceles triangle theorem, that says that the two angles across from the equal sides are equal to each other. So in 2A, I know that these bottom two angles are equal to each other. So that means angle A is 63 degrees. And the reason is ITT. In question B, if you notice that the two lengths that are equal are here and here, so the opposite lengths are equal. So this angle here is equal to 70 degrees, not x. I wasn't able to find x yet. I had to find this other angle that is not known, and I actually am not asked for, but I still had to find it. This may be easier to see if you turn your page so you can see the triangle on a different angle. So where this length would be on your bottom would be flat along your horizontal of your sheet. So now that I have that this is 70, I can now find angle x by taking the other two angles away. So 180, take away 70, and take away the other 70, which is 40 degrees. So to find angle x, I used ITT and I used AST. I used ITT to find angle 70, and I used AST to find my x value. But both were needed to get my final x value. In C, I'm told that this angle at the top is 50 degrees. I know it's an isosceles. These two angles at the bottom, which are across from my equal sides, are equal to each other. So I'm going to take away 50 from 180 to get 130 degrees. That means these two angles at the bottom both add up to 130 degrees. So to get x, I'm going to take 130 and I'm going to divide it by 2, which is 65 degrees. And again, my reasons are AST, because I had to use the fact that all the angles add to 180, and then I knew that the two bottom lengths were equal, so I used ITT. In question 3, I'm using the equilateral triangle theorem, which says that in an equilateral triangle, all angles are 60 degrees. So 3A, I can see clearly that this is an equilateral triangle. I want one of those angles, so it has to be 60 degrees. If you can't remember 60, you can just take 180 and divide it by 3, which is 60. In B, I want an angle on the outside of a triangle, but if you notice, this angle is along a straight line with this interior angle. So this angle outside of the triangle we actually call an exterior angle because it's on the outside of a triangle. This one on the inside of the triangle is an interior. So basically inside, interior, and outside, exterior. So because we know that this is an equilateral triangle, we know that this interior angle is 60 degrees because all three of them are. And then now that we know this is 60, we can find this exterior angle. We know that these two angles lie in a straight line. And when angles lie in a straight line, they have to add to 180 degrees. So I'm going to do 180 take away 60, which is 120 degrees. And I can see 120 makes sense because this exterior angle looks obtuse. My reasons? Well, first I used ETT to find the 60, and then I used SAT, which is a straight line theorem that says angles in a straight line add to 180 degrees. SAT, that's called supplementary angle theorem. So now you can finish 1B, and you can then go on to the next page and complete question 4, which is a mix of all the 3 different theorems that we looked at in this lesson.